have YouTube up, so if it doesn't start soon, I'll let you know.
So how you guys doing today?
Almost through the week.
Almost through the week.
That's all I can ask for at this point.
So how has the week been?
Interesting.
It's been a week filled with way too many meetings. A lot of stuff got done this week, but it is just, one of these days yesterday where it's filled with meetings. Today, there doesn't seem to be anything on the meeting calendar. And yet it's just, everything happens, except the end of time. It's a, so a lot's getting done with our astronomy magazine and such, but boy, what a week. It lets us relax and talk about something simple like, relativity.
Relativity. That's right. Although you had a big event this week, Dave. You gave birth.
I forgot I was going to do a shameless promotion and actually bring the books down. But I'll do that at another time.
All right.
A book called Galaxies that I had an idea that maybe I would do one back when I was 20 years old or something like that. And then finally I got a copy of it. It's coming out from Penguin Random House in 2 weeks. So bless you if you pick that up and read about galaxies. It's a big book and there are many, many images and diagrams and a sort of a right up to the minute understanding scientifically of what we know that has changed dramatically in the last 10 years about galaxies, but it does not cover all 100 billion galaxies, I'm ashamed to say.
100 billion or 2 trillion?
Well, I think that if you go back to the early universe, then our pal Chris Consolis was right. There were 2 trillion, but of course they combine over time. So maybe in the present day cosmos, there are only a paltry 100 billion.
Oh, but present day, you have now brought up the whole notion of time, which turns into a beautiful segue into the whole business of relativity.
A transition.
How about that? Cheers. We couldn't have planned that one better had we tried.
No.
Okay. Which to the audience, we actually did not
we didn't plan it.
So didn't plan it.
If they watch us all the time, they know that we plan nothing at all.
No, we plan nothing. That's right. That's right. Yeah, indeed. So relativity. So where, Dave, I'll just step back. Relativity, we're talking about Einstein in 1905 and the miracle year in physics, and how one guy, while working as a patent clerk in a Swedish patent office, manages to write papers that completely revolutionize physics. One in a way that his name was very much attached to, and one in a way that he always loathed. He sort of gave rise, he played a big role in giving rise to quantum mechanics, and then spent the rest of his life.
Yes, he did.
It. So tell me, what was physics like prior to 1905 or prior to the early years of the 20th century?
Well, and I think we'll get into the details of some of the cool stuff that we love to talk about with relativity in a moment. But this was really transforming our world. And one thing that's really neat about science is that it doesn't necessarily, as time goes along, show that the earlier scientists were wrong or fundamentally nuts or crazy or on wrong paths. But reality, the universe tends to be more complicated than we know it is as time goes along through various stages. So Isaac Newton, back in the good old 18th century, Newtonian mechanics, and possibly still the greatest book ever published, some would say, the Principia, defined the mechanical understanding of the way the universe works and the mathematical understanding. However, Einstein, that failed guy who couldn't, get good grades and flunked out and became a patent clerk in Switzerland, imagined what traveling very, very fast would be in frames of reference and came up with an entirely new paradigm for us to understand how the universe works. And we're still going through maybe even more sophisticated understandings of how that goes, trying to wrap quantum mechanics and everything else in with it, which Einstein could never do himself. but that was a quantum leap of understanding in a sophisticated
Back
way.
before there was such a thing as a quantum leap.
Yeah, this was a quantum leap to understand in a more sophisticated way how the universe works compared to the good old days of Newtonian physics, right? Is that the case, Allison?
Yeah, I think that pretty much sums it up. I mean, basically, yeah, up until that point, everything was defined by classical motion, and classical motion made sense in the everyday world. So
yeah.
That's why these things like quantum mechanics and relativity, I think came after. It just kind of comes naturally after.
Actually, it didn't make sense in the everyday world. Aristotle was the one who, no, objects naturally come to rest, and all of this stuff. It's funny, I was talking to a physicist friend a while back who had recently read Aristotle, and he said something that repeating it will send philosophers screaming and throwing rotten tomatoes at it and all sorts of things. But he said, you know how you get these crazy letters from wacko people who have a theory about the universe? And we all, I don't know. I mean, you must get these at the magazine, Allison. You see these things.
We get these.
Yeah. And I have
a lot
seen
of them in the Ask Astro inbox.
I have, yeah. And I have seen stacks and stacks and stacks of them. In fact, there are a few that I can't lay hands on one, but every now and then I'll get one that is sufficiently interesting or nicely bound or something that I'll sit on the shelf just to have it to, every now and then show people. But anyway, he was reading Aristotle, and he scratched his head, and he said, Aristotle kind of reads like one of those wacko letters that we get from somebody who just has a theory about everything. And ultimately, he's kind of right. Mm-hmm. And I, to be perfectly honest, I am not one to throw away history. I would never say that. But to be perfectly honest, I wonder why it is that when we teach philosophy, we spend so much time teaching Aristotle just so that we then have to turn around and talk about how more or less everything that he talked about turned out to be wrong when we actually got around to discovering how the world is. And again, I am now glad that we are online, because there are people out there who are throwing heavy, pointy, sharp, messy objects at us, or at least at me at this point.
They're computer screens, so they're, the computer's that's going to.
The Greeks are. That's right. That's right. But I mean, the way that I think about this is that we have our perceptions, we have our, the world that we kind of immediately experience, which is where I'm not trying, Aristotle was an amazingly sharp guy for the observations that he made. But all that he could do was say, all right, my immediate experience of the world seems to work like this. And one of the things that we have learned over time, and relativity is a very, very good example of it, is that as soon as you get outside of the box that evolution prepared our brains for, for us to be here, we had to be able to avoid things that wanted to eat us. We had to be able to catch things that we wanted to eat. We had to be able to find somebody to mate with. We had to be able to ourselves as groups against other groups. Those are the kinds of things that evolution prepared us for. Mm-hmm. And none of that involves being able to think about the world, how the world works when you're moving an appreciable fraction of the speed of light. None of that prepares you for being able to think about how the world works when you think about things that are truly vast in size, or things that are incredibly tiny in size, or evolutionary timescales or whatever. And so our brains kind of live inside this box, and we have a tendency to imagine that box is somehow real, that's giving us real information about how the world is. But every time, and I think it's true, that every time we have used the epistemology, the tools of science, to push beyond the walls of that box, what we have discovered is a universe that that behaves fundamentally different ways than what our intuition was, and that our intuitions are a special case of that broader reality. You know, we're talking about relativity, and so you talk about curved space-time and things like that, and it's the whole, okay, you look around you and the world looks flat, but if you go far enough, it turns out that actually it's curved. That's sort of a simple example of this. So
it's always more fascinating and more complex than we think at any given moment as the march of science continues. That sounds like a Sousa, piece of music. It's not, but things always turn out to be, frankly, more interesting than they were anticipated earlier. And we turn out time and time again not to be the center of it all either.
That's true.
We managed to make more and more convoluted arguments to make us the center, and those keep failing.
Oh, they do indeed.
Miraculously.
They do indeed. And scientists keep making those arguments even. We touched on that a few shows back, where the insistence that no, there can't be a multiverse is sort of the present day incarnation of, but wait a minute, it's not part of my immediate experience, therefore it cannot be.
Wait a minute. Are you saying that we've lost on all counts in the entire universe? Now we have to move on to other universes to be the center of things.
Well, yeah.
There's no center of ours.
No, we have to now. Okay, we personally turn out not to be the center of things, and the Earth turns out not to be the center of things.
Yeah.
And then the sun turns out not to be the center of things. And then the galaxy turns out not to be the center of things.
Yeah.
And then the universe turns out not to have any center at all. But we can still say that our universe, okay, we can still say that we're all that there is. And that's sort of the current, in my view, that's sort of the current boundary of this pre-Copernican notion of we being special.
Yes.
And anyway.
Yeah. Hey, Allison, relativity is full of all kinds of cool stuff. Like, everyone likes to think about traveling at very high speeds and the differences, frames of reference relative to travelers through space. Some people have even written songs about this, like our pal Brian May, 39. What's that all about? Can you tell us what's a little bit about this paradox of travel at high speeds?
Right. So, I mean, the most kind of simplest way to think about it and to put it is kind of something that I think most people know, either through, science fiction or whatever, is that the faster you travel, or the closer you approach the speed of light, the slower time appears to move. But again, I think the important thing to note is that it's relative. So that if you're traveling at, 0.7, 0.8 times this, c or whatever, and you're almost going the speed of light, to you, time is moving normally. It's not like you see your watch ticking slower and slower and slower. It would just be to someone else in, say, the rest of the universe who's not traveling at the speed of light, looking at you, that sees that it looks like your watch is ticking slowly, and vice versa. But we do know that that is true, that time seems to move more slowly the closer you approach the speed of light. And, for the rest of us, compared to that, we appear to be moving faster.
Except it's not, I'm gonna push for a second.
Yeah.
It's not that it appears to, and it's not that it seems to.
That's true. It actually does. Yes.
It's that it is.
It does.
Yeah.
Well, I was going to say, I mean, if you look at GPS wouldn't work unless you incorporate, these facts into them, unless you incorporate the fact that space-time is curved around Earth. It wouldn't work. So we know that this is a fact. Yeah.
So
and astronauts are microseconds younger because they've been orbiting the Earth for, months or whatever.
Actually, no.
No? Okay.
They are microseconds older.
Older, sorry, other way around.
Because it turns out that when you are in orbit, the special relativistic, the moving very fast time dilation is a smaller term than the general relativistic. That is, you're further out in the gravitational well. which
Mhm.
goes in the other direction. Yeah.
That is the other thing, is there is special relativity and there is general relativity,
Hmm.
and they're not the same thing.
Right.
So space-time being curved is general relativity, and time moving faster or slower is
So
not.
what was Allison, for you? And I'm going to ask you because you are closer to a point where you have fresh memories of this than are Dave and I. What was the first point for you when you were learning relativity, either special relativity or general relativity, that you heard something and worked it out and wrapped your head around it and just went, oh shit?
I don't know. It all made sense to me. I was like, okay, this is cool. I learned special first. They kind of
Yeah.
went from Newtonian mechanics to special relativity to general
Yeah.
relativity. I remember general
Yeah.
relativity being like, why are there so many terms and everything? I hate this.
Maybe
Maybe that was that point. I don't know.
You don't
Honestly,
like
I think
you don't like tensors?
I do not like tensors.
You
No.
don't like, oh, I love tensors.
I think for me, actually, the oh shit happened in quantum mechanics. For me, quantum
Mm.
mechanics is much less intuitive personally for me than
Right.
relativity. Relativity makes
Right.
sense to me,
Right.
but in quantum mechanics, that was probably the toughest class I think I ever took. I struggled through that one. Although I will
Yeah.
say, and this, I know this is off the topic, but in quantum mechanics, we learned everything in terms of you've got a particle in a box. I don't know if you recall this from your own quantum mechanics.
Oh, yes, indeed.
And
Yes,
I think
indeed.
I literally got to studying for the final when I realized, oh, you're just talking about an electron in an atom. If you had told me that in the beginning of the class, I would have understood everything. Instead, I'm literally trying to picture particles in a box, and it was so much harder. So I think they should just
Okay.
do away with that personally. So
Oh,
that's
but
why
no,
quantum
because
is harder
if you
for me.
do that, no, you don't want to do that, because now if you do that, you have to start worrying about coordinate transforms and doing the whole things in spherical coordinates, and you can't do it in one dimension anymore. You
know.
have to do it in three, and so you get spherical harmonics. And I'm looking, yeah, right.
I guess if they had just told me, we're saying it's a particle in a box, it's really, say, a subatomic particle, it would have made so much more sense.
Yeah. No,
Anyway,
so I think for me, maybe the thing that on quantum, oh no, we're talking about relative.
Sorry.
You had taken
I
my
totally
brain off to
derailed
quantum
the
mechanics,
conversation.
and I was about to start talking about tunneling. But
Tunneling
that,
is
and also what happens with polarization, and how in the world is it that photon that's polarized this way then winds up anyway.
Next time, or
Next
in a couple
time,
shows,
next
we
time,
will deal
yeah,
with quantum
right.
mechanics at some point.
Deal with quantum mechanics at some point when we've got the right. When we deal with quantum mechanics, we really do need to have something with a little better kick than a can of soda. No, I for relativity, I mean, there are things in teaching it, it's always fun because you throw things out there and the answers that you're going to get, and the answers are going to be wrong in ways that sort of blow people's minds. Like, everybody has heard of the twin paradox, and the way that they've heard of the twin paradox is that, okay, there are two twins, and one of the twins gets in a rocket ship and goes cruising off to wherever, some long way away, at close to the speed of light, and then they turn around and they come back, and time dilation says that when you're moving, that your clock runs slow, and so they come back and find that their twin was now a decrepit old man or whatever. And anytime you ask, if you're talking to a class, anytime you say, okay, so from the standpoint of the twin that was back behind, what was true of the clock of the twin that left? And they say, well, it was moving slowly. So, okay, that's true, that in the frame of reference of that twin that stayed behind, that time was passing more slowly for the twin that went away. And then you say, so in the frame of reference of the twin that's in the rocket ship, what is the watch of the twin that was left behind doing? And the absolutely natural reaction to that is, what answer does everybody give to that question when they first hear it?
That it was moving faster.
It's moving faster. Yeah, if they're wanted, mine must be moving faster.
Mhm.
And then you say, no, actually, from the frame of reference of the twin who's out there that the watch of the twin that was left behind is moving more slowly. And then people look at you funny and say, well, no, that's got to be wrong. What the heck is going on there? And then you say, okay, now let's think about it for a second. This twin was moving at almost the speed of light, the one in the rocket ship going out there, and was gone in the frame of reference of the twin that was left behind for 100 years. And so how far did that twin go? And the obvious answer is, well, they were going at almost the speed of light for 100 years. They must have gone almost 100 light years. Okay, fine. That works. So now let's ride along with the twin that's in the rocket ship. You know, how long does that twin's watch say that they were going? Well, they were going 1 year. Okay. And how fast were they going? Well, they were going close to the speed of light. So, okay, if they were going for 1 year and moving it close to the speed of light, how far did they go? Oh, well, 1 light year. Okay. So which is it? Did they go 1 light year or did they go 100 light years? Which is it? Were they gone for 1 year or were they gone for 100 years?
What's your frame of reference?
What's your frame of reference? Yeah.
Mhm.
And so it's another good one. I know it is the train in the tunnel. Allison, you know what you said as the
There
as
was
the
a horse in a barn.
Horse in the barn. Yeah.
Yeah. So do you know that one off the top of your head well enough to talk about it?
I don't think I do.
Oh,
There's
okay.
something about a barn that fits a horse exactly. But then the horse approaches the barn at the speed of light, and
Okay.
what happens? I think
All right.
that's what it is.
All I know is
Well-
if the horse is traveling that fast, it has to be Pegasus.
Or it's got to have a rocket ship strapped to it.
Trying to keep it real here, okay?
Right. Yeah. Yeah.
So time goes in
Well,
one direction. Time slows down as you approach the speed of light, right? But length appears to get longer as you approach the speed of light. So.
Well, no, length shortens when
Or
you-
sorry, length. Yeah.
Yeah.
See, I'm-
Yeah. And so your
Need more
watch goes
coffee.
slow.
I
That's
need
the
caffeine.
that's okay. The moving twin.
It's the time dilation and
Yeah.
the
It's
length.
that in the frame of reference of the moving twin, you say, all right, the moving twin was moving at almost the speed of light and traveled what seemed to the twin that was left behind, 100 light
much
years.
farther.
But from the standpoint of the twin didn't travel 100 light years. The
Right.
twin traveled 1 light year, because length is also not the I'm going to do it with the train instead of the horse. It's kind of fun. So you've got a train that's cruising along at close to the speed of light, and you have a tunnel, and the tunnel is just a little bit longer than the train. And so what happens is, as soon as the train is all the way inside the tunnel, you close both doors. And so you've got the train trapped inside the tunnel. And then you open both doors and the train goes on about its business and everything is fine. Okay, that's fine. But from the standpoint of somebody who is riding on the train, it's a very different situation, because in their frame of reference, what's happening is the tunnel is moving toward them at close to the speed of light. And since the tunnel is moving toward them at close to the speed of light, that means that the tunnel is small. It's shorter.
Mm-hmm.
And so somehow you get a train that is this long inside a tunnel that's that long.
You're going to have a dented door, maybe.
And you think, okay, you're going to have a dented door. This is just wrong. And that takes you into this other thing that you wind up with in relativity, which is the whole notion of relativity of simultaneity.
Mm-hmm.
Whether two things happen at the same time even depends upon your frame of reference.
Mm-hmm.
And so you have 3 events. You have the event of both doors closing and the event of the front door opening.
Mm-hmm.
And so what happens in the first frame of reference is both doors close, boom, and so the train is inside the tunnel, And then this door opens, boom. And so the train now can go outside the tunnel and everything's fine. So you say, what happened at the same time? Well, these two happened at the same time and this one happened later.
Mm-hmm.
And then you say, okay, but in the frame of reference of the train, what happened? Well, when you work that through, it turns out that the way that you get out of the strangeness, because either there was a crash or there wasn't. You know, there's a reality. It's not that the train crashed if you were riding on the train, but didn't crash if you were looking at it.
Mm-hmm.
So somehow, you know, the answer has to be that train gets through that damn tunnel without crashing. So in the frame of reference of the train, you know, the tunnel is a little short thing, but what happens there is that the train enters the tunnel, and just before the front of the train gets to the end of the tunnel, so the back end of the train is still sticking way outside of the tunnel, then the front door closes, boom, and then the front door opens, boom, and the train goes all the way through the tunnel, and then the back door closes. And so if you just ask questions like, which happened first, you know, this isn't quite which came first, the chicken or the egg. It's, you know, which happened first, the door closing or the door opening or whatever.
Mm-hmm.
And you say, oh, so in different frames of references, time passes differently. Links are different for different observers. And that in this case, for one observer, that happened. And for another observer, that happened.
Mm.
And there's just no experience in our daily lives. And as physicists, we get so used to it. You know, we wrapped our head around this long enough ago that all of this stuff is like, yeah, well, of course, that's how it works. Yeah, but fine. And one of the fun things, I don't get to teach intro students anymore. And that's kind of one of the few things about ASU that I miss, is I always enjoyed teaching this stuff to introductory students, just so you can take them through this and you can see the look on their faces. And yeah.
So what is going on now late in this week with this terrible dilemma that we're in with COVID-19, you guys?
It's also relative to where you live, apparently.
Texas, Arizona now, Dr. Hester, is opening up again.
Oh, yeah.
Tonight, with our Supreme Court in Wisconsin, the state of Wisconsin,
Yeah.
there were all sorts of people out at the bars here last night with no protection whatsoever. Isn't that right, Allison?
Mm-hmm. Yep. They just basically said, nope, you don't have the authority to close everything. So everything's now open and there are no rules.
So caution to the wind. We're going to get right back out there and sit on a crowded bar stool and drink.
Yeah. And very clearly, COVID is making massive contributions to Republican campaign war chests. It must be, right? Anyway, but no, that's a case. I mean, it's interesting. Pardon me. Yeah, you listen to what happened in front of the Senate. What was it, yesterday or day before that Fauci testified?
2 days, I think.
Was it 2 days or
Every
was it
day
yesterday?
seems like about a week to me now.
Yeah.
I think it was.
I mean, it was a
No,
couple days.
1,000 years.
Yeah.
Was it or was it? Anyway?
I feel like it was
forget if
Monday or something. It wasn't that long ago.
Okay.
But...
Yeah.
Yeah.
A couple days ago.
Okay. And it, you know, Trump got very, very annoyed with him, of course, because he got up there and without Trump breathing over his shoulder, he actually told, you know, he was allowed to actually speak truth. And, you know, the things that he said were like, no, that what we're doing right now is going to lead to a resurgence of the virus and that lots of people are going to die and that this is kind of a dumb way to do it. And yeah, he was upfront about it. And then I guess was it just today? I think it was just today that Bright testified, the guy that was the head of the developing vaccines.
Yep.
That got really annoyed when he was directed to start promoting the drug that the anti-malarial thing that Trump was on about. And he said, no, there's no science to support that. What we really ought to be doing is, really working on the pandemic for real. And that gets him fired. And I guess he testified about that today in front of the House. And again, got Republicans very annoyed at him. The thing though is, and we've talked about this, and I hate to get redundant, but what is going to happen is going to happen. There actually is a real world out there, and it doesn't make any difference what you say. It doesn't make any difference if your Supreme Court says whatever it says, or if Trump says whatever he says, or whatever, that the virus is going to do what the virus is going to do. And the people who actually are in a position to say, this is what the virus is going to do, are people like Fauci and Bright and folk like that. And so you can do a pretty good job of figuring out whether somebody actually believes in reality or not right now by looking at whether they look at what Fauci and Bright and people say and say, all right, that's what the science says, so that's what we need to deal with. Or people that say, oh, no, I don't like that because ideologically that's not what I want to be the case. And so I'm going to look for ways to discredit the scientist. But ultimately, reality wins that argument. It just does. And so what's going to happen now, and again, I don't want to belabor the point. I have personally, I've been thinking about this, and I have personally kind of gotten to the point that I realize that burning a lot of emotional energy being annoyed at these idiots, that's not going to change their behavior, so there's no reason to do it. But it doesn't matter. I don't have to get annoyed, because you don't have to wait for politics to correct what they're doing and what they're saying, because the virus is going to do it for you. And so when we open up again, and when things go up and they spike and people start dying by the droves again, and medical facilities are overwhelmed in places other than New York, and now it's not just a matter of saying we need to get stuff to New York, but we need to get stuff to everywhere. And the virus moves into rural areas where they wouldn't know what an ICU looked like if it, they just don't have that kind of care available. And when, what's going on in extended care facilities and things like that right now, all of those things are real. All of those things happen. And all of those things happen independently of whether Bubba decides he's going to take his AK-47 down to the State House and scream at people, or whether the Wisconsin Supreme Court decides that, well, if they ignore COVID, then that means, in law, if a court declares that something didn't happen, it didn't happen. And that's kind of the world they live in. But that's not the real world.
You're
and
saying
so
you can't pass a statute that denounces gravity.
No, you
Okay.
can't.
All right,
You can. It just won't be very successful.
I'm going to make a note of this now for the future. Okay.
Indeed.
Yeah, the atoms and molecules are not influenced by what anyone says anywhere at all. They're going to do what they're going to do.
The atoms and molecules are going to do what they're going to do.
Mm-hmm.
And what they're doing is cool. I don't know how much time you guys actually spend digging into the medical literature.
You assume I have free time.
Yeah.
How funny.
I am a very, very bizarre person. Quite often these days, my nighttime reading is reading annual review articles from medicine, or that kind of stuff.
The annual review, incredible.
Oh yeah,
great stuff. Yeah.
I'm reading an article from annual reviews right now about the application of the predictive coding framework for understanding the brain to understanding the relationship between psychoses like schizophrenia and things like autism. And I mean, it's just, okay, this is off of where we are now, except to say that again, any time that you push beyond the immediate boundaries of what you think you know from everyday experience, the world turns out being radically different. And that's the same for us. That we think, okay, I experience myself, and therefore I understand how I work, and I understand the notion of self, and I understand what consciousness is, and I understand all those things because I experience them and I just know. The reality, though, is that once you start digging into it with the tools of science, that our experience of ourselves is in fact sort of a strange approximation from a particular, now it really is from a particular viewpoint.
Yeah,
You know,
the stuff
there's
your
not-
brain does to fill
yeah.
things in is amazing.
Yeah, no, it is. But
You're breaking the hearts of the absolutists, you know.
I'm breaking the hearts of lots of people. I'm breaking the hearts of the dualists.
Yeah.
That's that's whose hearts I'm really breaking.
Yeah.
You know, the
Let me
idea.
ask you this, all those dangers, things are going to spike up, of course, and they're going to happen in pockets where people are together and they don't know they're carrying, perhaps they're asymptomatic, and a little grenade will go off, and this will happen in lots of different places in small areas here, there, and everywhere, presumably now. What about another complicated, we've already talked about how we don't understand this thing and some of these associated terrible inflammatory disease that's accompanying it, and other things like that that aren't just predominantly focused on the lungs. But what about when this happens a few months from now to coincide with the normal flu season, and we have a gazillion people who have a coronavirus ordinary flu, but we don't know whether that's this or just the flu. And I mean, this is going to be diagnostically a situation of total chaos, isn't it, in the fall?
And also, I mean, again, I have not looked into this at all, but I wonder, what, say, the race for a vaccine is going to mean for, the resources needed just to produce a regular flu vaccine. Is that going to impact it? Because I was just thinking, well, everybody get the flu vaccine this year, but is there going to be a shortage of that? Because either everyone's trying to get it, or they're trying to devote all these resources to maybe producing or even producing trial samples of a different vaccine. So
right, with these
also another complication.
Trying to even investigate new manufacturing ways to attach a needle to a preformed plastic syringe, even, so that they can be made in the numbers. I don't know that they can even get enough glass syringes for what we would need in the United States, because most of them all are made in other countries.
Yeah, I have well, my nephew's significant other spent a bunch of years working as an ICU nurse, working in that environment. And her statement about this whole thing was that the United States is not ready for triage medicine. And we've already seen, people might not realize it, but we have already seen triage medicine in places like New York, where it's gotten to the point where no, we are not going to treat you because we know you're going to die, and so we're going to use that treatment for somebody else. And that sounds like a very inhuman thing to do, except what else do you do?
There's no
I have one dialysis machine, okay, and I've got 2 people whose kidneys have failed because of COVID.
You got to make a choice,
and you have to make a choice.
This is like being in a MASH unit on a battlefield in some ways, in that sort of estimation.
And I know wife I've mentioned is a principal of an elementary school, and she was relating a conversation that she had just yesterday, talking to the, a meeting with superintendency, trying to sort of figure out where things are going. And of
Mhm.
course, an idea that people are pushing is that, well, okay, what we'll do is we'll open for a while until cases come up, and then we'll close and they'll come back down. We'll open for a while until cases come up, and then we'll close. And the point that she made that I don't think that they had thought about is that, okay, if we do this, then essentially what we are doing is we are being used as gatekeepers
Mhm.
to 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 limit the rate at which people die.
Right.
It's not that we are part of an actual solution to help people survive this thing.
Mhm.
It's not that we're doing anything to change the death toll of this, but rather what we're doing is we are using the schools to serve the economic argument that, oh, we have to have so many people in the workplace.
And
And
it's for two reasons. It's not only because, my God, we've got to do something with the kids and we can't just let education go forever, but
mhm,
it's that the kids have to go back to school to enable many of the parents to go back to work.
yeah,
And therefore, the schools are going to become the
yeah,
coal mines in
yeah,
which
yeah,
canaries live.
yeah,
Right.
yeah, yeah.
The virus carrying canaries.
Right. Right.
You're basically just sending all the kids to school so that everyone can get the virus, and then sending them all home and disseminating it through the population. So,
Yeah.
Mhm.
yeah.
And we are at an interesting time. We were, talking about relativity, the point that you think that you have a handle on the way the world is, and then
Mm.
along comes relativity.
Mhm.
And the thing about relativity and quantum mechanics is that at first blush you might say, oh, well, those are kind of interesting, until you actually grab a thread and pull.
Mm.
And the fact is that you can grab a thread anywhere in science. And I'm not talking about just physics. You can grab a thread anywhere in science
Mm.
as it existed, around 1900,
Mhm.
and start pulling. And what you find out is that the changes that came about because of relativity, because of quantum mechanics,
Mhm.
mean that the tapestry is going to wind up unraveling.
Mhm.
That the only reason that it looked like the tapestry was still there from the standpoint of somebody alive in the 1900s was that they had or the early 1900s was that they had yet to actually appreciate how far reaching the implications of this thing are.
Yeah.
And in the same sense, right now, we're very early in this thing. And if you go through the exercise, and this is just kind of an interesting exercise for people to do, grab a thread anywhere in our current concept of how the economy, how society works, and pull. And by pull, I mean say, all right, I'm changing this. And because I change this, that means these other things are going to be different. And these other things now affect these other things, and so on and so forth.
Mhm.
And I read an article the other day that talked about this in a very nice fashion, was talking about, look at Las Vegas, for example.
Mm.
The mayor of Las Vegas was, okay, we've got to reopen Las Vegas. We have to change the rules and let Las Vegas reopen. And the point of this article is that it doesn't make any difference what you do, because you can declare it to be open, just like you can declare it to be open in Wisconsin or Arizona or wherever you want to. But Las Vegas is an especially clean example of this.
Mhm.
And you say, all right, Las Vegas is based entirely on the notion that people will take expendable cash and pack themselves into airplanes to fly to a place where they are now going to pack themselves into casinos, and they're going to pack themselves into restaurants, and they're going to pack themselves into theaters, and they're going to lose lots and lots of money in what they consider to be entertaining ways. And that's what Las Vegas is based on. And of course, that's what the entire hospitality industry is based on. And that's what the schools are based on, because the schools, they're there to support those people, and so on and so forth. You can say Las Vegas is open now, but first of all, people aren't going to go there because people have a better understanding of this than politicians do, it seems. And if people do go there by the droves, it's going to become a COVID hotspot. And so it doesn't make any difference whether you say Las Vegas is open now, because Las Vegas doesn't exist anymore in the way that it used to exist. I mean, the buildings are still standing there, but what was Las Vegas has ceased to be. And no amount of judges or politicians or anybody else can change that.
For these people who are willingly giving away all their money to big corporations by gambling, is it really that much different if they're also end up dying?
That makes a difference to the corporations. Their income is now
I mean,
gone.
maybe this is what they want. I don't know. But we do have, I'm afraid we do have to wrap up today, because we actually have a late afternoon astronomy staff meeting, believe it or not, still to come today.
Okay, but tell me what you're going to be doing at that astronomy staff meeting again.
We're going to be welcoming 2 new editors, one for Discover and one for Astronomy, and we're going to be sipping a lovely beverage along with those folks via Zoom.
I have spent enough time in Wisconsin to know that sipping a lovely beverage is not the way that people in Wisconsin approach that particular activity.
I am not a native Wisconsinite, so.
Have you spent any time in Madison? I have to ask
yes.
Allison. Have you spent time? I know that Dave has.
Not extensive time. I've been there for a convention or two, but like a day at a time. So unfortunately, not as much time as I would like.
I used to spend a fair bit of time in Wisconsin once upon a time, back in Space Telescope days. I really do think that Western civilization, in some sense, is based around sitting on the terrace, drinking beer and eating brats and watching, people sail out on Lake Mendota or whatever. But I mean, they're serious about it. If now maybe bar crawls are a thing of the past, but once upon a time, man, if you wanted
not
a
in
bar
Wisconsin
crawl,
as of last night.
my participation in bar
there you
crawl
go.
may be a thing of the past. All right, so you guys have to go and have fun at a get together that you're going to call work, but actually involves using the arrival of a couple of new editors as an excuse to drink like cheeseheads, right?
Exactly right.
All right. That's
a perfect scientific analysis.
There you go.
All right, so we ought to say Monday. Is it Monday, Allison?
Yes, Monday.
Tell us about Monday.
Monday, we will have a special guest star. My sister is a therapist who is working in Chicago and living in Chicago, actually lives right downtown and works downtown as well, has been working from home. But we kind of wanted to highlight the mental health aspect of all of this. It's been very hard for a lot of people, mental health wise, whether you're affected, by a job loss or, a family member loss, or literally just stress. There's been a lot of things where people feel like they shouldn't feel bad because they still have a job or still, or no one has been sick, and that's not the case. So there's been a very big mental health impact on pretty much everyone because of this. And so I'd like to talk about that and get some firsthand experience and advice.
Mm-hmm. Oh, I look forward to it.
We'll see you Monday.
Yes.
We'll see you Monday. Take care. And we're still live because I'm sitting here staring at the, I am, oh, well, okay. I'm going to go up here and end this in another way.
Live forever.